So please do this class opener as quickly as possible. Remember, the x-axis is the horizontal axis, the y points to the sky. These coordinates right here are ordered pairs. You want your x first, your y second. So we have our coordinates listed right here. Now let's go for quadrants. Remember, this is your first quadrant, second quadrant, third, fourth. So where is point A at? It's in quadrant 1. That's right. So I'm just going to put a 1 right here. Where's point B at? Quadrant 2. Point C is between 3 and 4. Okay, it's between 3 and 4. Remember, quadrant 1, 2, 3, 4. And D is between 1 and 4 or 4 and 1, whatever. But it's between 1 and 4. Let's move on to the actual notes for today. Today we're going to learn very important section, functions and relations. Okay, so in this section we need to define and understand what a function is and compare it to a relation. By the way, a function is a relation. We'll get to the better understanding in a little bit. So I want you to draw this. Put a little light on it. As long as it has a window, that's what we want to look for, because we're going to eventually look inside this window. Please draw it. You can make it as detailed as you want. In a couple of seconds, I'll tell you to stop. So as you can see, we're going to be putting in values into this machine. Something's going to happen in here, and we're going to get out values. So after you draw this, it's a machine. This is what we're going to call a function machine. A function's like a machine. This is a function machine. Now what I want to do is I want to plug in a number, like the number, let's say, give me any number. 4. I'm going to plug in the number 4. And when I take this number 4 and put it into this machine, something's going to happen to the 4, and it's going to come out a 9. Okay? Give me another number. 6. So let's plug in the number 6. I'm going to change colors so we can see it here. I want to take the number 6, plug it into this machine. Something magical is going to happen in here, and out is going to come the number 13. I know you're thinking, what's going on? Okay, so far we plugged in a 4, plugged in a 6, got out a 9, got out a 13. Give me another number. 8. Okay, I want to plug in an 8 in green. This 8's going to go into this machine. Something's going to happen, and it comes out as, does anybody know?
17.
Oh, goodness, 17 is correct. Huh? Some of you got it already? So the question is, what is happening inside this machine, in this window, right? So if we zoom in, what's happening in there? This is what's happening inside the machine. Y equals 2x plus 1. Now, I know we're not thinking of equations. I mean, what some of you did notice, like Mark, take the 4, double it, add 1 to it, you get out a 9. 4 times 2 is 8, plus 1 is 9. 6 times 2 is 12, plus 1 is 13. 8 times 2 plus 1 is 17. Right? So your inputs go into this machine, and what's happening in there is you're plugging it in, you're multiplying the 4 by 2 and adding 1 to it, and this is the algebraic function that describes that. So maybe I should make it thicker. So I'm taking the 4 and I'm plugging it in to the x value, and then you have 2 times 4, that's 8, and 8 plus 1 gives you 9. And see, that 9 is really a y equals 9 now. My 6, I plug it in. Where do I plug it into? X, right? Into the x. And then I go 2 times 6, because I plugged it into x, plus 1, that'll give me 13. I take the 8 and I plug it into x. 2 times 8 is 16, plus 1 is 17. So it's pretty obvious that the numbers that are going into the machine are called inputs. Yay? Because you put them into the machine, right? The numbers that are coming out, let me zoom out a little. The numbers that are coming out of this machine are not inputs, they are outputs. Make sense? Yeah. So all of these words right here, input, domain, x values, those all mean the same thing. Now, why would we call these numbers x values? Well, because we're plugging in the 4 into the x. We're plugging in the 6 into the x. We're plugging in the 8 into the x. And after we work it out, we have y equals whatever your answer is. So that's why these numbers out here are no longer called x values. They're now called y values. Does that make sense? Okay. Now so input's easy, you put it in. X value's easy because you put it into the x value. Output's easy because those are the numbers that come out. Y value's easy because those answers are your y values. Now the only one they have to memorize, make some effort for, is domain. These numbers that are going in, they're called the domain. The answers that are coming out, those are called the range. The only trick I know is think alphabetical order. D comes before R, so D is going in, R is coming out. Make sense? And there's one more word that I want to add to each of these lists here. So let me do this. Let's zoom in to the input domain x values, which all mean the same thing. And let's also throw in another phrase. We're going to put independent value. Independent value, or values, independent values. And I might as well put a cloud around this whole thing because all of these mean the same thing. Now, why would I call the inputs my independent values? What do you think I want to call my outputs if the inputs are the independent values? Dependent, that's right. So on the output, those are the dependent values. And again, I'm going to put my little cloud around that thing because all this list of words, they all mean the same thing. They're my y values, they're my answers, okay? So why are the x's called independent and the y values called dependent? Because my x's, those are numbers that you're just giving me. Those are independent. You plugged in a 4. But this 9 that you got out, it actually depends on you plugging in that 4. Make sense? Like if this 13 is completely dependent on the independent 6 that you plugged in. If you didn't plug in a 6, if you plugged in a different number, you wouldn't get 13. So that's why 13 is dependent on the 6. Does that make sense to everybody? Yes. So the most important fact of the day is being able to identify when you actually have a function or when it's just a relation. So Austin, right here it says, for each input, there's exactly one output. That's the number one factor of understanding when you actually have a function machine, all right? For each input, there's exactly one output. So let me try to make sense of it. Up here, I plugged in a 4, right? What did I get out? A 9. And then I plugged in a 6 and I got out of 13. I plugged in an 8, got out of 17. What if I were to plug in a 4 again? What would I get out again? A 9, right? So for each input, there's exactly one output. If I plug in a 4, I get out a 9. If I plug in a 4 again, I get out a 9 again. Now, what if I were to plug in a 4 again and get out a 15? Then this machine's broken. Then it's no longer a function machine. It's just some type of relation. Make sense? It's kind of like, I always use the analogy, kind of like if you have a tortilla machine, you plug in some dough, you get out a tortilla. Plug in some dough, get out a tortilla. That's a machine that works, right? But what if one day you turn on this machine, you plug in some dough, you get out a tortilla, you plug in some dough, you get out a donut? What the heck? That machine's broken, right? It's no longer a fully functional tortilla machine. So in order for you to consider a function, it has to be a working machine. For each input, there's exactly one output. So let's take a look at down here. We have a list of inputs and a list of outputs, right? Is this a function? Is it a machine that's working, or is it a relation, or is it just a relation, a machine that's broken? Okay. Now the thing is this. I don't even need to find the actual, I don't even need to describe what's going on inside the machine. The question is this: do I ever plug in the same input 2 times and then get out different answers? No. I plugged in a 1, I got out of 3. I plugged in a 2, I got out of 4. I plugged in a 3, I got out of 5. Plugged in an 8, got out of 10. I mean, I never plugged in the same number twice and got out different outputs. So just by knowing that I didn't plug in the same number twice, I already know it's a function. It's a machine that works, right? So everybody put an F right here, not as in flunk, but this, what you see here is a function, not a relation. Okay, that's a function. Now, I mean, you could take it a step further and say what actually is happening. What's happening from the 1 to get to the 3? You're adding what? 2. Is it consistent all the way through? Add 2, add 2, add 2. All right. So, if you wanted to go the extra mile and say what the machine actually is, if you wanted to say what's actually happening inside the window, you'd put y equals x plus 2. Because all you do is take your input, which is an x value, and add 2 to it, and you get your output, which is a y value. Now, you don't have to do this part, all right? All you got to do is put an F or an R, and that's all you have to do on the first part of the quiz Friday. Domain and range is the same thing as input and output. It's the same thing as x and y. So is this a working machine or is it broken? So if it's broken, we cannot call it a function machine, right? So what do we call it? Relation. So let's put an R right there. What? That is not an R. Here we go. That is an R. That's a relation. Okay, why is it a relation? Check it out. I plugged in a -3 and I got out a 15. And then I plugged in a -3 again. I'm supposed to get a 15 out again. But notice I did not get a 15. I got a -10. That machine's broken. Make sense? Yeah. And there's going to be tons of these questions on Friday's quiz. It's really simple if you understand the concept of a function being like a machine. Is it working? Yes. All right, it's a function. Is it broken? If it's broken, then it's no longer a function. It's just a relation. So let's move on over here. Now you're probably thinking, wait a minute. These are just coordinates. That's right. Coordinates are x and y values, inputs and outputs, domain and range, independent values, dependent values. All those words mean the same thing. So is this machine working? It looks like it's not, huh? But again, the key words are, for each input, there's exactly one output. Do you ever plug in the same number twice and get out different answers? No. So this machine is working. I know, you're thinking, wait a minute, but it all produces 3s. That's like having a bunch of tortillas. That's great. It's a fully functional machine. If I wanted to actually describe it, which you don't have to, but let's actually describe it, y equals, I would say 0 times x plus 3. That way, no matter what you plug in for x, that'll give you the output 3. Do you see how this is a machine that works? Yeah? It's not broken. You're not plugging in a 4 and getting out a 3 and then plugging in a 4 again and getting out a 20, right? So it doesn't matter if all your outputs are the same. For each input, there's exactly one output. Do you ever plug in the same number twice and get out different answers? That's when you know the machine's broken. Okay, so let's move away from just looking at numbers or just looking at data. Let's start looking at graphs and being able to determine if you have a function machine or a broken one that's called just a relation. Now, if we take a look at this first one, what we could do is, do you guys see any input-output values? No. Okay. Do we have coordinates on this line? Yeah. Aren't those input and output values? So one option is to actually start doing, okay, 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, -2, -2, and you could make a list, 1, 1, 2, 2, and you could tackle it that way, right? You could look at those inputs and those outputs. Do you ever plug in the same input and get out different outputs? Do you ever plug in the same input and get out different outputs? No. So this machine is working. This is a function. This is a function. Let's put an F right here. Now, I'm going to teach you a better way. It's called the vertical line test. The vertical line test. Now, what is the vertical line test? So you see this vertical line right here, this blue one? What we're going to do, you could use your pencil and just run it up and down and just hold it right here next to the edge of your graph. And as you move your vertical line from left to right, does it ever touch your line at more than 1 point at a time? Does it ever cross at 2 points? No. Like right here, there's 1 point. 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 What this is saying is that for each input, there's exactly one output. So the vertical line test is super easy. Why? Because you don't have to think about these numbers. You don't have to think about inputs and outputs. You just take your vertical line and you run it like this sideways and check if it ever touches your vertical line at 1 point. So like right here, it only touches right there at that point. Over here, it only touches at that point. Never does it touch at 2 different points. Let me show you one that does. Let's go down here to this guy. See right there? The curve actually touches our vertical line right here and right here. Now, what does that actually mean? Let me move the line from there. That actually means that for my single input, I get two outputs. So for the input 4, now this is a coordinate 4, 2, and this is a coordinate 4, -2. So right there, obviously, you could see that the machine's broken. You plugged in a 4, you got out a 2. You plugged in a 4, you got out a 2. What if you plug in a 4 again? You're supposed to get out a 2 again, but right here it gave you something totally opposite. It gave you a -2. Does that make sense to everybody? So the vertical line test, you don't even have to think of numbers. All you got to do is take your pencil or your finger, whatever, something that's vertical, and run it left to right. If at any point it touches your graph at 2 locations, which clearly it crosses here and here, it fails the vertical line test. So we just call this a relation. So let's continue. How about this guy? Does this one pass the vertical line test? Is this a function or just a relation? It's a function. Never does it touch at 2 locations. So this one right here is a function. Put an F right there. You're going to have to do this on the quiz Friday as well. Okay? Let's go to, we already said that one's a relation. It doesn't pass the vertical line test. Does this one pass the vertical line test? Yes, it does. So what do we call this one? Function. Let's put an F right there. Function. You see? It's easy. Let's go to this guy over here. Now, I don't know if you could see it. It didn't come out that great, but right here we have a vertical line itself. Okay? Does this one pass the vertical line test? No, it has all the points overlapping, right? And you could only have 1 point on your vertical line. So this one's a relation. Okay? Now, if we were even to think about the coordinates, we might as well. This dot, that dot, that dot. That's the coordinate 2, 3, the coordinate 2, 2, the coordinate 2, 1. And we could see that the input 2 gives us a bunch of different outputs. That's a totally broken machine. What do you guys think? Let's do one more, just for kicks. So like, let's say I had this. So here we have our XY plane, X, Y, and we have this squiggly S-looking graph. Is that a function or a relation?
Relation.
It's a relation, right? Let me even take this a step further. If I asked you for the input 0, how many outputs do you get? 3. Remember, for the input 0, that's X, how many Y values do you get? You get 1, 2, and 3. So that's probably like the coordinate 0, 1, the coordinate 0, 6, and the coordinate 0, -4. So the input 0 gave you 3 different outputs. So this is definitely a relation, not a function. So I'd put an R on this one. Let's move on to this final part down here. Determine if the graphed coordinates on the class opener represent a function or a relation. So if we take a look at the class opener, let's check and see if it's actually a function or a relation. Class opener. So we have a bunch of coordinates here. I could highlight them in red. A coordinate right here, B, A, D, and C. Are those coordinates representing a function or just a relation? Does it pass the vertical line test? Look, is there 2 dots on this blue line? How about now? How about now? How about now? So does it pass the vertical line test? Yes. So what is this? This is a function. You with me?
Yes.
Okay. So for number 1, it is a function. Let's circle the function. It's not just a relation. Please state the range of the class opener. Now this is super easy, and this does come out on the quiz. Let's go back to the original, and let's state the range. Guys, remember that all these words mean the same thing. Output, range, Y values, dependent values, all those mean the same thing. So when I say state the range of the class opener, I'm telling you to state the Y values of the class opener. 4, 3, -2, and 0. So let's write that down over there. So there it is. My range is 4, 3, -2, and 0. How about the domain? The domain of the class opener. What are they really asking us to do with the class opener? The X values, which would be 3, -1, 0, 4. 3, -1, 0, 4. And that is my domain, my X values. Now let's go to this true and false question. If you have 2 different domain values producing the same range values, it cannot be a function. True or false? You have 2 different inputs giving you the same exact output. Is that a broken machine?
No.
Bless you. Let's look at this guy. Didn't we have different inputs here giving us the same output? And that was a perfectly working machine, right? So you could have a function that gives you all the same outputs. So right here it says it cannot be a function. So that would mean this is a false statement because, yes, it can be a function. So let's write down false on that guy. The last one, if you plug in 3 and you get out a 4, and then you plug in a 3 again, but you get out a 2, then it's not a function, it's only a relation. What do you say about that?
True.
That's true. That's a broken machine. So this is true right here. There will be a couple of true and false questions on the quiz. Be ready for that.